And coming up after the break, turning incinerator waste into building material. We'll have an expert to tell us more about that and other innovations that take recycling to a higher plane.
Next on First Look Asia. Games, gadgets, gizmos galore. Techno's top 5 returns with our picks for the month of April. Got a great product idea or thriving brand under your care? On World IP Day, we'll bring you some expert tips on protecting your intellectual property. And don't miss our special interviews with the cast of Captain America: Civil War. All on First Look Asia, Tuesday.
Guys, get in.
Nice car.
Extreme boldness. The all-new Elantra. Hyundai. Got the best mix. Class 95.
Dare to take on the financial markets? Get ready for Trading Talents Asia Pacific.
Join the first ever TV Trading Challenge in Asia Pacific as Investor Insights teams up with Saxo Bank Group to search for the region's top trader.
6 weeks, 20 finalists, live trading strategies, and $30,000 US at stake. Sign up now at tradingtalents.saxo.
Nobody expected anything like this.
Welcome back to Singapore Tonight. Thank you for staying with us. Now, as you may know, the newly launched laboratory by NUS and Sembcorp is planning to develop sustainable solutions in 3 core areas: energy, water and waste. Known as Corporate Lab, the $60 million collaboration aims to boost innovation in Singapore's R&D. Now, one of its projects is going to include converting waste from power plants and incinerators into useful construction materials. And here to tell us more on these exciting innovations is Professor How Yong. He's Director of Corporate Lab. Prof, welcome to the show.
Hi, Don.
All right, so the 3 areas that were chosen, namely waste, water and energy, tell me why.
Basically, there are a number of reasons that compel us to pursue research in these 3 areas. First, Sembcorp core business is to develop, own and operate energy, water, waste to resource facilities. And all these are related to the 3 areas. Second, NUS has expertise and excellent R&D track records in these 3 identified areas. So with the convergence of these interests, it is natural and logical for us to establish this partnership to pursue research in these 3 areas.
Right. So let's look a little bit more closely at those 3 areas. We'll start off with waste management here. Of course, I understand that what we're thinking of doing, or it's already in the process, is to turn incineration ash into a type of building material.
Right.
So tell me why and how
Yes.
that's done.
So we are looking into using fly ash, which is a waste generated by biomass or coal-fired power plants.
Right.
And we're going to produce ultra-lightweight but strong cement composites. It is very light that it can float in water. Right.
Right, so I mean, we have a picture here
Right.
of the type of a 3D building model. Tell me
Yes.
something about how it will work in that.
Right. So we are using these cement composites to build buildings. So the picture here show the modular components of a building.
Right.
So what we do, the concept is like Lego, you know, whereby modular components of a building are made in the factory, brought to the site, and assembled into a building.
Right. So it has very important applications in construction and so on. Let's move on to the next area in relation to water. As far as that's concerned, lots of industries, of course, we know use water. So what are we doing in terms of helping them to recycle and use that wastewater?
So the key approach is to reduce industrial wastewater discharge. And water reuse is one of the key approaches. So in this diagram, you can see that factories in the industrial park, the wastewater are transported by gravity to a wastewater treatment plant.
Right.
And in this treatment plant, you go through treatment of this wastewater and advanced purification techniques to produce high quality reclaimed water.
Right. So tell me something about those techniques. We've got biological processes here. That means literally using bacteria and so on to break down certain elements?
Exactly. So first we use a biological process where there are a lot of microorganisms to convert the organics present in the industrial wastewater into, for example, carbon dioxide. All right, and from there, the treated wastewater can further be purified by advanced processes.
Right. So essentially, it makes the water not drinkable, but they can, you know, the industries can use it again. And then, of course, there is also reverse osmosis. We know something about that.
Yes. So basically, after this industrial wastewater has been treated, we will use these advanced purification technologies such as reverse osmosis, electrodialysis reversal process to produce high-quality reclaimed water.
Right. So the third area, Prof, energy, of course, always a big concern. How can we actually, you know, improve on energy efficiency as far as industries are concerned then, and produce less emissions?
Yes. So if you look at power plants, either they are using natural gas as a fuel or using other materials like coal or biomass. So one of the major challenges in coal-fired boilers is that ashes can deposit on the boiler's water tubes and superheaters, and that will create resistance for the efficient heat transfer from the flame to the
So that's
water.
what we're looking at this in this picture, sort of like deposits that have sort of built up over time.
Yes, exactly.
As part of the process of the factory.
Yes.
And that creates a type of insulation, as I understand.
Exactly.
A little bit about science.
Right.
Evidently.
And, yes. And in a very worst scenario, you can even have corrosion that cause damages to the water tubes.
So all of those basically combine to lose energy, as it were, make them less energy efficient.
Yep.
So tell me something about what we're looking. This is a model of perhaps a typical power plant.
Right. Yes. So this shows the various components, key components in a power plant. And one of the major concerns is that how can we ensure this power plant don't have any failure? And we can't afford any failure. Yeah. Otherwise, you got electricity shortage, you know, and blackouts, for example. So in order to prevent that, we will conduct research on condition monitoring and advanced predictive maintenance.
Right.
So the idea here is to install sensors on the key component of a power plant, monitor the signal, the electrical signal, and we will develop an advanced algorithm to analyze this signal so that we can predict way in advance when this machinery is going to fail.
Right, because there's so much that could go wrong with such a complex power plant of this nature. Thank you so much, Professor Ng, for sharing all of that with me. A very interesting topic, and all the best with what you're doing and achieving. I've been speaking